Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video exemplifies the simple method for selecting the best multiple regression model detailed in the previous mini-lecture. Let's get started. So if we look back to the model that we saw in a previous mini-lecture where we're looking at predicting the height of a daughter from the height of the parents, we can illustrate this concept of using different factors that influence a decision among several multiple regression models. So the methodology that we saw in the previous mini lecture about this is how we choose from the model. We're looking at adjusted R-squared values, we're looking at p-values, and we're using sound judgment, typically looking for models that are simpler and don't have the complexity of more variables. Let's illustrate how this applies to the model that we made earlier, where we were predicting the height of a daughter based on the height of her parents. So for that model, the adjusted R-squared value is 0.637. Not really a super duper value, but it's decent. P-values was listed as less than 0.0001, which is practically zero. And zero is the best p-value you can have. So we're all aces in that category. Height is a genetic trait. So it makes sense we could actually use a model that says, hey, the height of the parent is going to influence the height of the daughter. So that kind of makes sense. So there's our sound judgment piece. So by itself, our model looks good for making predictions. But is it the best model to be using for making predictions? So you could have two different models. They're each making decent predictions, but is one of those models going to be consistently better at making predictions than the others? See, that's the thing. We want to come out with one model that's the best at making predictions. How do we get that? Well, let's take a look here. Look back at our data set here. We see the heights of the fathers and the mothers that were used and the heights of their daughters. And this is the data that was actually used to make our model with. So using the heights of parents as predictors, we can make different multiple linear regression models. And we can compare those with one another and find out, which is the best model for making predictions. And then once we know that, then we can figure out, okay, so what's the best estimate for the height of a daughter, given that the father is 71 inches tall and the mother is 65 inches tall. Let's examine how to answer these questions, and we'll take them in turn one at a time. So first up, the first question, using the heights of the parents as predictor variables, which regression model is best for making predictions? At this point, we need to actually make the different models, but to do that, we have to list the ones that we could make given the variables that we have. So we have to actually make a table for each of the different combinations of variables, and then also include a column for the adjusted R-squared and the p-value. So we're going to start by making a 3-column table, and we have our headings here. So we've got predictor variables, p-value, and adjusted R-squared. So we could use the father as a predictor, or we could use the mother as a predictor. We could also use the father and the mother together as predictors. So there's 3 different models that we can make here, and we're going to have to make each one of them, get the p-value and the adjusted R-squared value for each one, and then compare them like we saw in the previous mini-lecture. So the next thing we do is we're going to list the sample space for the possible predictor variable combinations, and that's what you see there in the table. Now we're going to finish our table by making each of these models. So because of the assumptions that are built into StatCrunch, we have to make these one at a time. Now, there's software that I used out in industry that you could actually just put your data in, and it would make multiple models and list them there in the table for you automatically, and then leave you to choose which one you wanted to actually use. StatCrunch is not like that. Because of the assumptions that were built into it, whoever was coding this didn't think that you would have or should have the need for making multiple models at once. So you're making models one at a time. But that's okay. We can do that. Go to Stat, Regression, Multiple Linear. And then in the Options window, you're going to select the daughter as the Y variable. And the father is the X variable for the first model. So we just select that one. And then away we go, hit Compute. And then we get our results window here. Here's our model. Remember, the p-value you want to take is going to come from the ANOVA table. The adjusted R-squared value you can see at the bottom of the results window there, the 0.0497. So there's our p-value. We'll list that there in the table. There's our adjusted R-squared value. We can put that in the table. And now we go through and we're going to do the same thing for the other two models. And we just keep making these models one at a time until our table is complete. So we do that. Here's what we get for completed values in our table. So now we've got the tabulated values. Now we can apply the method that we learned in the previous mini lecture to find the best model for making predictions. The last two models have the best p-value. So they have a p-value of 0. The other model that's left, the first one we made for the father, has a non-zero p-value. So we're just going to eliminate that from our consideration right from the get-go. Then to select between the two models that are left, we're going to look at the adjusted R-squared values. Notice the value of adjusted R-squared is about the same. I mean, there's really not a whole lot of difference between 0.63 and 0.62. I mean, they're really next door neighbors in the same neighborhood. But, you know, the one model has two variables and the other model has one variable. So we're going to select the model that is the simpler one because the adjusted R-squared value is not providing that much differentiation. So we're going to take the model that's the simpler one. So using the height of the mother to make a prediction for the height of the daughter is the model that we're going to be using. Now we can find the regression equation for this model, use it to make our prediction. Of course, you have to make the model to get the p-value and the adjusted R-squared values. So you just go back to, whatever run that was, or go back to your, the options window and just, select the mother as the only predictor variable. And away you go. You can just hit compute and there's your model that comes out. This is the results window that you see when you do that. And we can see that up here at the top, there's our regression model. So this is the model that best balances the different factors that we have to consider. And that's where the sound judgment comes in as well. You're looking at a balance between three different factors. And the best model is usually the one that provides the best balance between these different criteria. What's the best estimate of the height of a daughter whose father is 71 inches, whose mother is 65 inches? Well, we know what model is best from our regression analysis, so we're simply going to use it to make our prediction. So here's our model. We're going to plug that value of 65 in for the mother. Notice it doesn't matter how high the father is because the father is not a variable in our model. So all we need is the mother. So we plug that in for the mother and we punch out the math and out comes 64.7. So this is the prediction, the best estimate for the height of a daughter. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.